Good morning, good afternoon, or good evening, depending on where you are in the world. My name is Sharon Florentine. Welcome to today's Security Boulevard webinar, which is a container live hack, continuous application security for your OpenShift workloads, brought to you by Snyk and sponsored by Red Hat Marketplace. We are super excited for this webinar today, at least I am. But before we get started, I need to go through some housekeeping items with you. Please remember that this event is being recorded, so if you miss any or all of it, you will be able to go back and watch it again. We will send you an email with instructions for accessing the webinar on demand, or you can always visit us at securityboulevard.com/webinars. It will be there for you as well. Please note, we've got some handouts and a PDF in the Handouts tab on your console that you can download and reference now or at any time after the webinar, so go ahead and grab those. There's also a link in the chat that you can click on and sign up for a free account. So I suggest you take advantage of that, folks. Great resource there. We are taking questions throughout the webinar, so go ahead and use the Q&A tab on your console and submit questions at any time. We will try to get to as many as possible at the end of the presentation. Anything we don't get to, we're going to send right over, and our speaker, Tomas, will be able to get back to you offline. Finally, stick around until the end because we're doing a drawing for 4 $25 Amazon gift cards. So stick around and see if you are a winner. All right, so with that, I am going to formally introduce our speaker today. Tomas Gonzalez is a partner solutions architect with Snyk. And Tomas, I'm going to turn my camera off and put myself on mute and let you get right into it.
Fantastic. Thank you for that delightful introduction. Super excited to be here and to have prepared a good what I believe is a good presentation for you all. I hope you enjoy it. We're going to be talking about continuous application security for OpenShift workloads and specifically how Snyk can help you ensure that your applications as well as their dependencies that you're deploying into an OpenShift environment can stay secure. So diving right in, first, just a brief agenda of what I'll cover. I'm going to show you 5,000 slides. I'm kidding. I have about 7 slides to go through before we get into the session. So first off, a little bit about Snyk. Snyk, we're all about helping companies develop fast and stay secure. What does this mean? Is we're all about helping you make sure that the software your company builds, every company's a software company nowadays, is built securely, the code from the ground up. This includes your code, your open source, your containers, and your infrastructure as code. We started in the open source part of that equation back in 2015. Since then, we've grown tremendously. We've been through 5 rounds of funding, exploded massively in terms of employee growth, as well as expanded our product portfolio. Now, we've built our product and our platform around 2 realities that modern software shops are seeing. First is that everybody's going through their digital transformation. This is reshaping how the businesses are structured. If you hear about DevOps, you've heard about process, people, and culture changes. And with that, it has also changed how software is built as organizations move to a more agile delivery cycle, embrace technologies such as continuous integration and continuous delivery. Second, with that adoption, with those changes to modern development cycles, traditional methods of security, where security was an afterthought, later down in the process, where if you can imagine a wall between development and security, development would throw things over the wall, security would do their thing, they would throw the results back. That approach doesn't work anymore now that we're looking at multiple releases per day. So with that, there's been this whole movement, this new approach about shifting left, introducing security earlier into the process. And that's where Snyk can help. So if you think about how the cloud has facilitated this transformation, before the cloud, a developer would have to worry about the code they wrote, the open source components they use, and then there would be another team, a T or operations, where the developers would request a server. I need this server, this many cores, this much memory, this much storage, these firewall rules, these network connections. And that process took some time, like sometimes months, between the time a server was requested and when the server became available. Fast forward to the cloud. Now, all of this is sitting at the developer's fingertips. Developers in the cloud and with automation technologies like Terraform have the ability to request servers in seconds. And case in point, the OpenShift cluster I'm using for today's demonstration was created in IBM Cloud in a matter of 20 minutes. So no more waiting for months in order to test my applications that I'll be demonstrating today. So what does this mean, though? It means that developers are now responsible for more than just the code they write. They're responsible for more than just the open source they use in their application. Suddenly, they have to become experts in the containers they package their applications into. This might include hardening operating systems and doing things that they typically were not used to doing. So overall, there's more risk that developers are responsible for nowadays. So where does this risk come from? It really comes from developers not having what they need to tackle problems early. Now, to give developers the security tooling that they need to address these problems proactively, you often hear about shifting left. Now, shifting left works when security is introduced early. Now, security becomes more than just a developer's responsibility in a modern delivery cycle. Developers, the operations team that's responsible for maintaining the uptime of the application, as well as the security team responsible for making sure the company doesn't get breached, they all need to align and come together on what is an acceptable level of risk, what are the tolerances, and what are the risks we're willing to tolerate introducing into our environment. So while many people believe that developers should actually own security, a lot of those people also believe that developers don't have the necessary tools. So what do? We talk about shifting left through developer empowerment, but enabling the rest of the organization to have a say through guardrails, through policies that feed into the developer's decision-making process, where security issues can become part of the normal daily backlog developers are working through. So how does this translate into the modern application? If you think about a modern application, the application will consist of the code, right? This is the secret sauce, frequently bringing together, gluing various open source components. This is the intellectual property that the developers write for their companies or for themselves. Now, that is what they can control. If you dive under the water to the other pieces of the iceberg, though, the developers might be also bringing in open source components. Open source has become ubiquitous. Over 80 to 90% of a code base can now be open source. It just doesn't make sense for a developer to write their own authentication module. It doesn't make sense for a developer to write their own markdown processing module. All these components of the application that are available in the open source realm are a simple npm install away for a lot of cases. And just because open source is free, there is a hidden cost to it, like in terms of making sure that dependencies stay up to date, that there are no vulnerabilities in the open source components that you're bringing in. And this also applies to containers. Containers might introduce hundreds of open source dependencies in the form of the operating system that the application runs on. And then consider the cloud equation I was measuring earlier, where environments can be quickly provisioned as code in minutes instead of months. All these environments need to be properly configured. Do not leave your load balancer open to the world. Do not leave your S3 buckets open and unencrypted. These are all considerations that the developer who was previously just used to writing code and perhaps choosing good open source now has to consider. So how does Snyk help? Snyk provides what we call the Cloud Native Application Security Platform. On the left side of the screen, if you can see, this is a typical GitHub repo for a cloud native application. It might have the container definition in the form of a Docker file, the open source components in the form of a gem file. In this case, it's a Ruby app. The custom code, as well as the infrastructure as code. If you look through many GitHub repositories nowadays, you might see some of these files. So what Snyk aims to do is provide the capabilities to test these different bits of the cloud native stack for issues, integrate that testing throughout the software development lifecycle, wrap that around a great developer experience built for developers by developers to empower them to own the security, take it into their own hands, and be proactive as opposed to reactive with keeping their application secure. And you can't really do that without being able to trust that the information being provided in the application is legit. So Snyk's dedicated security team makes sure that the information provided is actionable, it's accurate, and it's timely. And then to help that message of shifting left is not enough, we're wrapping all that functionality around enterprise governance features that allow operations and security teams to participate in the process, not just be bystanders or an after the fact. That's the kind of cultural shift we're looking to enable. Now, what makes us different? As we go through the demonstration today, we're going to focus on a few aspects. First is we're going to focus on developer empowerment. So how are the tools that we're providing developer friendly? We're going to take you through a journey of a developer working in their IDE. We're going to show how we can integrate into the source control provider to test code when pull requests are opened, as well as have ongoing monitoring for vulnerabilities that may be disclosed. We're going to talk a little bit and demonstrate some of the automated fix functionality that helps accelerate remediation, and then dive deeper into how some of that security expertise manifests into helping developers validate that some of the vulnerabilities we surface are actually applicable to their application. Now, from a high level, here's what I'm going to be demonstrating. We're going to be showing how Snyk is introduced into the coding stages. We're going to be looking at Snyk in the source control system. We'll demonstrate in GitHub Actions the integrating Snyk into a continuous integration and continuous delivery workflow. This is something that can make operations teams very happy if they can prevent or gate deployments, if you will, that introduce vulnerabilities. How we can connect to the container registry to make sure that an image that we have in production no new vulnerabilities have been disclosed for an image that might be running in production. And then also talk about how at runtime, we can identify possible misconfigurations and vulnerabilities in running images. So with all that, let's get started with the demonstration. So I'm going to first start in our GitHub repository to give you an overview of the application that we're going to be working with today. So this is our sample application goof. You can find it on GitHub. This repository is available for anybody that wants to play with it. This is a Node.js application that can be packaged into a container using its Docker file. And in it, you have also some manifests that deploy this application to OpenShift. We can see some that deploy the application itself, but also the database that it requires. And so from a very high level, it's possible to just take this, clone it to your desktop, and start working with it and deploy it as is. As a matter of fact, we've started by deploying the application. Here it is running in an OpenShift environment. It's like, yay, it works. So this is a basic to-do list application written in Node, deployed as a container into OpenShift. Now, at a very high level, it looks harmless. You might be thinking, oh, it works, so it must be great. But now we're gonna dive into some of the invisible risks that our application is introducing simply by the choice of open source that we've declared in our app. So our journey begins in Snyk. And in Snyk, we have used the GitHub integration that allows you to just simply tell Snyk, here are the repositories that I'd like to import. So if you decide to try Snyk, configure your GitHub integration, immediately you're going to see, oh, here's all the repositories that you have access to. In this case, the one I've imported is goof rhpds. Once you add the repository into Snyk, what Snyk does is it looks for files in those 4 categories I mentioned earlier that can be scanned, where we can identify security risks, license risks, configuration risks. When the import completes, you'll see, oh, here's a package.json file. These are the open source dependencies in our application. We have the Docker file that defines how the application is packaged into a container. We have the analysis of the code. This is with our new product, Snyk Code, that does static application security testing on the code base to make sure that developers, through their decisions and the way they implement code, they're not introducing security or quality defects into their code. Then we have the infrastructure files that I demonstrated that control how this application is deployed into OpenShift. So to get us started, we'll start with the open source dependencies. We did promise a little bit of a live hack component. So let's look at how the application deployed into OpenShift, because of the open source that was bundled into it, introduces some ways that where an attacker or a malicious actor can exploit a vulnerability in a component to do things they shouldn't be able to in the application. So before I do, let's first look at the anatomy of an issue in Snyk. So in Snyk, every issue is organized by our proprietary priority score. I'm going to show something else around the priority score later, so remember this term. The priority score considers a multitude of factors, and it's designed to help, once you scan your application initially, answer the question of, where should I start? So we're looking at factors like how long the application or the component has had a vulnerability published against it, how old is this version of the component that you're using, is there an exploit available for this vulnerability, is there a fix available for this vulnerability, and most recently, we added the ability to identify social trends, perhaps if vulnerabilities are being talked about on social media. All of these different factors factor into this one easy to consume score. The ones at the top of the list are the most important ones. Now, each issue card has information such as the module that introduced it. In this case, this is a zip-slip vulnerability introduced by ADM zip 0.4.7 that was fixed as of ADM zip 0.4.11. So what do we do to fix this? Simply upgrade to ADM zip 0.4.11. Now, the question that a developer might have as they start looking at this defect is, does this actually affect my code? If it's available, now some of the vulnerabilities that are listed, you might see this information is pretty consistent across all the different vulnerability cards that we have. But if we navigate to some other vulnerabilities, there are, if it's available and it has been discovered by our security team, you will see additional information that allows you to, analyze and construct this and think about, oh, am I using this code in such a way that opens itself up to attack? If it's available, we also display the vulnerable module, so that as a developer that's familiar with their code, if you can see that, oh, I'm actually calling or using this vulnerable function, then we can then use that to think, okay, this is something we should fix. Now, we also provide additional information about vulnerability. So if you can go to the National Vulnerability Database, you can see the CVE information. But part of the work our security team does to augment the information provided inside Snyk is we synthesize the information from the National Vulnerability Database. So here's all the attack vectors. But we also provide additional information that can be used to learn more about the vulnerability, perhaps even construct an exploit so that you can validate this against your code. Now, let's look at this in a live hack context. So there's a vulnerability introduced by the ST package in our code. It's a directory traversal vulnerability that allows you to exploit a way in the way this package is applied in the code to perhaps leak the contents of a file, like on the file system where the application's running. If we go into the vulnerability details, then there is some information that can be used to potentially construct an exploit. So as a developer, I come in here, I read about the vulnerability, and I get an idea, is this something that might actually be exploitable in my code? So for the purposes of this demonstration, and for those that are interested in trying it themselves, we've put together a collection of exploits within the Goof repository's exploits folder. So a lot of the components that I showed you in the issue list that do have exploits available, we've constructed some exploits so that you can play around and use these exploits to learn the real world implications of a vulnerable open source component. So let's play around with it and see what it looks like. So first off, I'll start by taking the address where our application lives, because we need to be able to target the running application in order to exploit a vulnerability. Ideally, you'd want to do this before the application's in a running state, open to the internet and in production. But for today's demonstration, to make it as extreme as possible, we're going to be running this against the live application. So I've cloned the code over to my Visual Studio Code repository, or IDE, excuse me. And I'm in the exploits folder right now. The very first thing that I need to do if I want to play with any of these exploits is I need to set an environment variable that says, hey, where's this application running? Now, once I set that environment variable, like any of these exploits, for example, the ST exploit that I was demonstrating in the Snyk UI earlier, the first thing, if you cat these folders, it shows you like what is actually doing when you run some of these aliases. So if you source this file, then now all these aliases are available as commands. So if I do, bit by bit, I could start exploring how, okay, make a curl call to this, and I get some information back. ST2 gives me a little bit more information back. Now I'm starting to see, oh, look, here's some directories, like where my application's running. Go straight into the end, and you might be able to see the contents because this is an exploitable path. Like by running this carefully crafted string against the running application, this is the directory traversal vulnerability. You're able to leak the contents of the etc password file. So what do we have here is we have sensitive information that might be leaked simply by running an exploit that's documented and available in the wild against an endpoint that is exposing a vulnerable open source component. So what can we do about this? There's actually a couple things that we can do to take action against this. First off is we know from looking at the Snyk user interface that the vulnerability is fixed in version 0.25 of the ST package. So we can just upgrade the open source component and hooray, it's fixed. This vulnerability is no longer going to be exploitable. But we also have other packages, other vulnerabilities introduced by the same ST package. This one's fixed in version 1.2.2. So a couple of options where we can target this, because we might want to try to fix as many vulnerabilities that we can in a single go without introducing too many breaking changes. In this case, how can we upgrade this ST package to tackle multiple vulnerabilities at once? Well, one way to do this is to go to the remediation tab inside Snyk, and we can see that the single upgrade from ST024 to 122 fixes 4 vulnerabilities, including a high severity one, 2 mediums, and a low, including our directory traversal vulnerability that we just played with. Now, what if I don't want to go into the Snyk user interface? I want to get the results right into my IDE. So Snyk and Red Hat are working together on an IDE plugin called Dependency Analytics. It's free to use. It can be installed from the Visual Studio Marketplace. It's also available for IntelliJ IDEs, where if you're looking at the package.json file, where you're declaring open source dependencies, here we have the vulnerable ST module. Then right here within the IDE, we can present information about the recommended package to upgrade to in order to fix this particular issue. So if I just by hovering here, I can see, I can fix this problem by upgrading to version 2. Or, as the Snyk UI recommended, I can upgrade to version 1. In this case, I feel brave. I'm going to jump 2 major versions from version 1 to version 2. If I click Fix Problem, View Problem, then I can get more information about the vulnerabilities in the output section below. Or if I don't really care about the problems and I just want to fix it, I can hit Quick Fix, which will switch the dependency to version 2. And with that, we can then start, pushing up changes up. So we go back here. Let's go ahead. Let's make sure. Okay, yes, I modified my package.json file. Fantastic. So we'll add that to the package to my commit, and we'll commit it, and we'll call it fix ST vuln by upgrading ST, and push that. So while that pushes, The dependency analytics extension does more than just give you point-in-time recommendations for single packages. You can also click the button in the upper right corner to generate a report of all the issues across all the dependencies. So this will be the same information that you can see within the Snyk user interface, just within the IDE. So looking at the vulnerabilities that we have, for example, in the ADM zip package, we can see the same information, such as, okay, what version is the current version? What version is the one that we recommend to fix this vulnerability? And you can click on the links within the extension to go straight to the knowledge base information. So the same information that you can get within the Snyk user interface is available in dependency analytics right within the IDE, so that you can quickly find the information you need to help fix the issue. Now, when this now pushed my code, so let's go back to Snyk. Now, one of the benefits of using the GitHub integration is that Snyk sets up a webhook to the file, so that if changes are pushed to the GitHub repository, where we're monitoring the package.json file, we will retest the file automatically. You can actually configure how frequently you want these to test, whether it's daily, weekly, or you can wait until the webhook tells it, there's a new update for this file. But in this case, in the interest of time, we'll go straight into our package.json file. We'll ask to retest it, which will just reach out to GitHub, get the new version of the package.json file, and rerun the analysis. And once it does that, we should see that the directory traversal vulnerability that was introduced by the ST package should no longer be present. But in this case, I did something wrong. Oh no, the demo gods are not with me. I wonder what I did wrong. But that's the expected experience, is you go to the IDE, you fix the vulnerability, you push the code up to GitHub, and Snyk will retest the file to make sure that the vulnerability is actually gone. So one way to test this to see if I'm trusting that the vulnerability didn't actually get fixed. If it had been fixed, this exploit that I was running earlier should no longer work. According to Snyk, it hasn't been fixed. So if I run this exploit, yep, it's still there. So I didn't do something correctly. Oh, I didn't save my file. Ha, that does it. So let's try this again. No, that should have done it. So if not, I digress. So that's one potential way that, and your choice of open source dependencies can introduce risk into your application. You declared an open source component, it looked harmless enough, your application works, and then suddenly you have a defect that can be exploited in your app. Second way that you might see risk introduced into your application is, we talked about your container Docker file. Your container Docker file introduces many open source dependencies that are in the form of operating system packages. Now, depending on the container base image that you use, you might have more packages, you might have less packages. So what we're doing here effectively is identifying, okay, what is the base image that you said you want to use? In this case, it's Node 6 stretch. It's like, oh, so what other base images could you potentially upgrade your container to that have less vulnerabilities? This is what Snyk is looking to provide. We try to help you address as many potential vulnerabilities as possible without, having to address them one by one. So in this case, you have 931 vulnerabilities. You can potentially knock that down to 535 simply by upgrading Node 14.7.2. You might be able to go even lower, upgrading to Node 16.4.1 Slim with 59. That has a total of 59 vulnerabilities. So in this case, we can either open a fixed pull request, which effectively upgrades the from statement in the Docker file, or we can triage and look at the vulnerabilities individually. We see the same information still ranked by the same priority score that we were demonstrating earlier, to help you figure out, what should I actually be fixed? In this case, let's go brave, and we're going to upgrade to Node 14.17 Buster. So by clicking the Open the Fix Pull Request button, what this is going to do is it's going to check out a new branch against our GitHub repository. and it's gonna then change our Docker file. We can look at the file diff view from node 6 stretch to node 14.17 buster. Now, here is where automation and DevSecOps transformation really comes together with the right technology. So you might have, as part of your workflow, checks. In this case, you might be able to use GitHub Actions for continuous integration. What you'd want to do is not take any of these vulnerabilities and trust and recommendations and trust them blindly. There's no guarantee in this case that upgrading from version 6 to version 14 of your of the node runtime powering your application isn't going to break something. So what would we do as developers? We would take this Snyk fix branch that Snyk created for us. So if I take this, for example, and I return to the IDE and I try to check out that branch, then I don't know why that branch isn't checking out. It's like it thinks it doesn't there. So you check out the branch, you build your container, you run the container, you make sure your application still works, and then you can, if once you're satisfied with the results, you can then ensure that this is safe to deploy to production, and things are going to be okay. So in this case, just to be brave, I'm going to submit the pull request that created earlier, and we're going to see what happens because we're brave. Now, a couple of things are happening. In this case, I check this into our develop branch. So our develop branch is our working branch. This isn't actually the branch that is deployed into the OpenShift environment. So what I'm about to do is create a pull request to the second branch that I have. In this case, I have a deployment branch. We're going to compare the develop branch against it. In this case, we fixed the vulnerability in ST. We fixed the base and selected a more secure base image. So let's create that pull request. And call it fix vulnerabilities. Now, as part of this pull request, Snyk is going to run a couple of checks. So first, it's going to make sure that no new issues that weren't already present are being introduced. It's also, and on the security side, and it's going to check for the same thing on the license side. I feel pretty good about this change. This isn't an important application, so I'll go ahead and merge it. Now, I have a GitHub Actions workflow set up that is now going to take this code that I just merged, rebuild the container, push it to the Quay registry, and redeploy it into OpenShift. So that takes around a minute or so to run. I wanted to, while that's running, moderators, I wanted to see if there was any questions that had come in so far in the chat, or if I should just continue.
It looks like Jorge wants to know, can I use Snyk with Azure DevOps?
Mm-hmm. Great question, Jorge. Absolutely. So I'll go into the Snyk product to kind of assist as a talking point to what I'm going to show you. So let's go to snyk.io and we'll sign into the application and go back into Snyk. So our integrations for continuous integration systems, we do have a plugin that can be used with Azure pipelines. Now we also have them for other CI systems. We have the ability, you have a CLI option if you're using a CI system that's not listed, or if you want more control over like the analysis that Snyk is running in your pipeline, you do have the option to use the CLI. Now, similar to what I demonstrated with GitHub, Azure repos is one of the supported options. So if you're using a hosted Azure repos on the cloud version of Azure DevOps, or if you're using a hosted or a self-hosted on-premise version of Azure DevOps, you have the ability to connect to it as well using the integration. Thank you for that question. Were there other ones that came in?
Let's see. Someone wants to know about career opportunities at your organization. So maybe you'll get some new colleagues soon. Let's see.
Yeah. Yeah,
Um,
we're always looking for new friends. I guess I'll drop that in here. Just go to snyk.io/careers. Check out what we have. Definitely. Yeah, we're
cool,
always
cool.
looking for new friends.
There you go. Um, Here's a good one. How do you run Snyk locally as the developer, or do you consume it as SaaS and integrate it into your pipeline?
Great question. So both. So you have the ability to, as I was showing, we have IDE plugins that you can use to get the same information from the Snyk UI within the IDE. This includes our open source scanning. I haven't shown this yet, but it also talks about it also includes our static analysis functionality that allows you to look for things like SQL injections, cross-site scripting, and other quality issues in your code. Also, that same CLI that I mentioned can be used locally. So if you wanted to, for example, run a Snyk test, you can install I need to install it. Perfect example. I can install Snyk. It's a small NPM package. And with that, you can run the Snyk CLI locally. So all these great questions. Let me see if that bought us enough time for the new container image to have been pushed. All right, so it looks like it hasn't quite pushed it yet, but it is working. So I think I
Want
have
me to
time for
show
one
you
more
another
question.
one? Okay.
Yeah.
What centralized vulnerability management solutions does Snyk integrate with? Examples, Kenna, Code DX. I've not heard of that one, so my apologies if I just screwed up the name.
Ooh, well, the container build just finished, so I'm not going to answer that.
Okay.
Just kidding. Just kidding. So I'm already in the integrations page. So way at the bottom of our integrations page, we have a couple that you can integrate with. You mentioned Kenna. Kenna has built a plugin for Snyk, so you have the ability to ingest our vulnerabilities into Kenna. We do also support CodeDX, RIS, and Spring Vulkan.
Mhm.
And all of these are powered via our API. So if you have a vulnerability management solution that's not listed in here, all of our it's the same APIs under the covers. You can check out our API documentation and apiary, which allows you to pull information and do all sorts of weird things with the data from our platform. So,
Cool.
great questions.
All
Thank
right.
you for helping me fill that time. I appreciate it.
Hey, no problem.
So
That's what I'm here for. I'll let you get back
yeah,
to it.
absolutely. So a couple of things happened while we did that round of questions. So we checked in code into our deploy branch. Once it's in the deploy branch, it triggered a GitHub Actions workflow. The GitHub Actions workflow essentially constructed the Docker image, then pushed it to a Quay.io registry. So if we go into Quay.io, we should be able to see that it was pushed fairly recently, 4 minutes ago. Beautiful. And one thing I didn't show within Snyk is that we have the container registry integrations that I had mentioned earlier. So we can see that image that right within Quay, last tested 2 hours ago. So if I go back to the deploy tag, I ask Snyk, yo, retest my image. There's a new one in there. Of course, Snyk will do this automatically on a schedule, depending on how you configure the retest. But you can always force it by going into the UI and telling it, retest it now. And we should be able to see that this Node 6 17.1 base image was actually now upgraded to Node 14.17. And if it didn't, then I set something up incorrectly in my demo pipeline. But I trust myself for this particular thing. Now, what should also be happening after the image gets pushed into Quay, we should have our deployment on OpenShift should have registered. Let's see that a new version of our goof application was pushed. So if it didn't, then we can always just go into the deployment. We'll bounce the pod. And we're going to tempt the demo gods once more by bouncing this pod, scaling it to 0, scaling it to 1. It should deploy the new version of the application that has the ST component vulnerability fixed. which means that our exploit should not work. And if it does, then I definitely did something wrong under the covers. But we're human, it happens. So let's see. Now that I bounced the pod, let's give this a shot. Find the right exploit. Ooh, it worked. I did something wrong. I don't know what it did, but I'll have to troubleshoot this later. But it worked in the practice run. What did I do? But anyway, let me get through the rest of the demonstration. If we have time, we'll continue troubleshooting it, and it'll give something exciting. So we looked at open source vulnerabilities. We also looked at vulnerabilities that can be introduced through your container in the form of your container-based image. Now, if you want to check out a vulnerability that is introduced in the Node 6 base image, there's a wonderful image magic exploit that allows you to insert files into the running containers file system. So that one, I kind of forgot my own demo flow and already updated the base image of the container. I should have done that before doing that. Silly Tomas. But the point being, container base images can also introduce vulnerabilities in the form of Linux packages. Now, we also talked about infrastructure as code. Infrastructure as code can be, and by Snyk terms, are both the Kubernetes manifest files that tell OpenShift how to spin up the application. It also includes Terraform CloudFormation files that you might be using to spin up the cloud infrastructure itself. So in this case, we can look at the deployment manifest of the application as we deployed it into OpenShift. And what Snyk is doing is it's looking for against a database of rules, which if you'd like to check out the rules that we evaluate against, snyk.io/security rules has the rules that the infrastructure as code product has, if you'd like to check some of these out. So for Kubernetes, we're looking for things like the container running in privilege mode. Are you mounting the Docker sock? Are you running without CPU and memory limits? So these rules all manifest within the Snyk user interface in the project screen. And what we'll do is we actually try to highlight, for example, if I click on, I'm running without CPU and memory limits, like we actually try to highlight, where in the file, is this happening? So running without liveness probes, where would you apply that? It's like, well, you can resolve this by adding a liveness probe attribute. Are you running with a writable root system? You can resolve this by setting a security context on the read-only file system to true. So we're looking to present this information in a way that helps the developer actually resolve the issue, giving them just enough information so that they can, if they know what to apply, great. If they don't know what to apply, they can easily look up in the Kubernetes documentation or elsewhere, how to set a security context for a read-only file system. Now, since the question was asked you earlier about using the Snyk CLI, I need to fix my Snyk installation, but you do have the ability to install this. You do have the ability to run the same scan that you saw within the web user interface locally. So before committing code to GitHub or your source control system of choice, you have the ability to just Snyk test, point it at the manifest file, and right in the command line output will tell you the same security rules that you just saw in the UI, as well as how to fix them. So the idea is run test early, test often in the IDE. You can test for the open source issues, the container issues. You can test for the code issues by using our plugins, and you can test for the infrastructure as code issues. See, this works. No, I need to fix my path. Not smart. And so with that, I think it's a good segue to the last bit that I wanted to show is the code analysis. I gave you a preview of this in the IDE. We have a plugin that you can use to see this exact same information. But if you look at the issue cards of a code analysis defect, they look a little bit different than the open source ones, because what we're doing is we're actually showing you where in the code, information went in, how it traveled through the different parts of the application, how then it exits. And then in the fix analysis column, we give you information about the defect. How can you prevent, for example, a command injection defect? And then example fixes where, based on the training set for the Snyk Code AI engine, how have other people out in the public internet, in GitHub in this case, fixed, in this case, a command injection vulnerability? And for example, here you can look in the commit status and you can see, I removed this whole mess of code and I replaced it with this. And this is how this particular person was able to fix a command injection vulnerability. Now, the recommendations will be different for defects because they are context aware, or they try to be. And the Snyk Code engine was trained on public GitHub repositories. So if you try this out for your applications and you see the same vulnerabilities that I do, you might not see the same recommendations and fixes that I'm seeing. So now I talked about the individual components of the Snyk platform. What I haven't talked about is the enterprise governance feature, right? How does Snyk help turn security into a team exercise? I showed you the developer's life within Snyk, test in the IDE, look in the web UI by connecting it to the source control repository. But how would somebody like an operations team or a security team benefit from this? Well, this is related to Jorge's question earlier. Like, if by using our CI plugins, for example, which are based on the Snyk CLI, it is possible to use arguments from the Snyk CLI in the CI pipeline to break your build in the case of vulnerabilities. So, for example, like setting a severity threshold that only fails the build if there's higher critical severity vulnerabilities. And further tuning that to only fail the build if there's vulnerabilities that have an actual fix, or going into the UI and being able to ignore vulnerabilities that either don't have a fix or don't need to be fixed. So this is how an operations or a security team, in collaboration with development, could define rules of engagement around what is and is not allowed to enter the production environment. Just insert the right checks in place. Couple things that I didn't show today that we have shown in other demonstration. Snyk has a set of GitHub actions that can be used to potentially prevent risky merges into the code. These are all powered by a CLI. For those using OpenShift pipeline, we do have a collection of Tecton tasks that can be used for adding Snyk into OpenShift pipelines. If you're using Jenkins pipelines on OpenShift, you can use our Jenkins plugin. So this is kind of where the operations team can be kept happy by helping them ensure that you're not introducing risky things into the environment. Security be happy about that too. But the other piece I wanted to demonstrate where security can definitely participate in the process is in the form of policies. So policies allow organizations to come together and agree on what's allowed, what's not allowed, and then all the enforcement mechanisms that I just showed you inherit the information from the policy engine. So to give you an example of how that works, for example, you can create a security policy that only applies to projects that you've designated as business critical front-end applications running in production, where if there's an exploit that has been published and is mature or in a proof of concept state, you can then change the severity of a vulnerability to critical, for example. So this would potentially allow you to take a medium or a low severity vulnerability that has an exploit available, report it as critical, which could then be gated by the CLI or in a continuous integration pipeline. The same also applies for licenses. Like if you wanted to add a rule that says, no high severity defects or risks allowed in the pipeline, same thing, set the project criteria, the evaluation criteria for the policy, and then select the severity of adding a particular license. You do also have the option to add instructions for a developer. So, if you have a 0BSD license and you wanted to give an instruction to a developer saying, BSD license is not allowed for any reason, contact someone in legal. What this would do is when the developer runs the Snyk test, or when they're looking at the information in the Snyk UI of a particular component that has this license, it would give them instructions and help them move forward instead of just saying, you can't use it. So other areas, of course, reporting's available in the product. It breaks down the information into issues. You can look at the dependency tree, generate a bill of materials. You can generate a license report. You can see where issues might be present across multiple projects to help prioritization efforts. And all this would manifest in the experience that I've demonstrated today. Now, how can you get started with Snyk? Apologize in advance that my super interactive cool demo on OpenShift didn't have all the showmanship elements I wanted to demonstrate today. But for those of you that want to try this out, and you will have better luck than I did, you have the ability to go into your OpenShift cluster, search for Snyk in the operator hub, find our operator, which of course can take you to the Red Hat IBM marketplace to purchase Snyk. So you can procure Snyk from the marketplace. You can bring your own license if you're already a Snyk client. And the operator allows you to monitor the applications as they are in a running state. So what that translates to is that if I go to this and I select a workload from OpenShift, this is the operator deployed into the OpenShift cluster. And I wanted to scan a particular workload. What this does is it allows me to monitor the workload in the source control system, in the CI/CD pipeline, in the container registry, and again at runtime. In this case, this is the Mongo database that my application requires. This is not something that I developed internally, but I still want to be aware of the issues that it has. I can see the same information that I was seeing for the other vulnerability, for the components of my application within the UI. But I can also see other elements such as the configuration of the application. For example, I'm running my Mongo container without CPU limits, without memory limits, without, as a read-only file system, without dropping capabilities. But I am not running as root. Yay! So this allows you to have a holistic view across multiple points in your software delivery lifecycle, where you're testing the applications as they go from ideation and concept to actually running in production. So I know that was a lot. Covered more and less than I intended to during this demonstration, but I hope that inspired you to try it out for yourself in your applications. There is a free Snyk offering available, so you can go to snyk.io and sign up. There is a link at the end of the presentation that I demonstrated where you can collect that link if you need it. But with that, I'm gonna just go back to the slides and see if there are any other questions before we wrap up.
All right, let's see. I think we probably can squeeze in one or two more here. Let me see what we've got. What if a customer's running their repository in a private VPC? How do you connect into a private VPC?
Ooh, going straight for the hard questions. I see you. So we have a component. If you're running either a GitHub Enterprise server or a GitLab or Azure repos, we have a component called the Snyk Broker. The Snyk Broker effectively, as the name implies, handles communication between an on-premise source control system and the Snyk SaaS offering. Snyk is a solution delivered as a service, all in app.snyk.io. So our broker allows you to connect the public Snyk offering on snyk.io with your on-premise source control systems. It also allows you to limit the information Snyk sees So for example, I demonstrated with public GitHub that here we got access to the package.json file, the Docker file, all the manifest files, as well as the code. And you can use the broker to tell Snyk, only the package.json file or only the Docker file. So the broker serves two purposes in that case. It helps connect to the on-premise source control system, but it also helps you control your access keys, and it helps you control what file Snyk has access to for testing.
Okay. All right. I think that is all the questions we have time for, though. Some really great questions, folks. Thank you so much for sending those in. If you sent a question in, we did not get to it, my apologies. We will gather all these up, send them over to Tomas, and he will be able to follow up with you afterwards. Just as another reminder, this session has been recorded, so if you missed any or all of it, you'll be able to go back and watch it again. We'll send an email with instructions for accessing it on demand, or you can visit us at securityboulevard.com/webinars as well. Also, folks, don't forget to check out the handouts tab on your console. You'll be able to download the slides and a cool PDF for some reference material you can take with you. And if you haven't already, use the link we sticky noted in the chat there and sign up for a free Snyk account also. All right, so it is now time for us to do our Amazon gift card drawing. So we're going to do that right now. Our first winner today is Ben F. Congratulations to Ben. Next, our next winner is Ramon H. Congratulations, Ramon. Michelle B. Congratulations, Michelle. And our fourth winner today is James F. Congratulations to you, James, and congratulations to all our Amazon winners. We will be sending you an email with instructions to claim your gift cards, so keep an eye on your inbox. If you don't see it there, please make sure to check your spam folders. All right, with that, thank you all so much again for joining us today. Thanks, Tomas, for that amazing presentation and demonstration. Really, really cool to watch. Really great information. We appreciate it. Thanks to all of you for spending your time with us today. We hope to see you again soon at another Security Boulevard webinar. With that, I am Sharon Florentine, signing off.